So the rise of metallurgy in Eurasia, a bit pretentiously called, but that's how you get your funding these days, if you know, whether you're dreaming or you're rising something. It will be about, say, 20-something, 25 years. I started when I was 15, just to let you know, to work on archaeometallurgy. So like 25 years or so of working in the metallurgy. So a lot of articles that I've written, put together, but like in a different way, with results from our joint adventures, I have to say, research adventures with DBM, but also with other institutions that helped us and reveal more of these how and why behind the early metallurgy in Eurasia. So yeah, I'm like just start. Should start. Yes, there it is. Perfect. I just want to get rid of this bar. Fine. We all like the earliest and the oldest, and I have been guilty of it as well. You know, these sensational titles, the eye catchers in newspapers and in media, and I'm responsible for this one, and I think this one. But you can see that this fascination with the earliest doesn't really leave us. We want to find the earliest and the first, and how did it all happen? So the origin is a very fascinating topic. But there's a lot to actually unpack when we talk about the origins of, say, metallurgy in Eurasia, for instance. It all started, as you know, with selecting beautiful green stones somewhere in this, Near Eastern region, Iran, Turkey, and so on. But turning these rocks, the green and blue rocks, into metal really requires a bit more knowledge. And the way we see it in the archaeological record, or that we wish to see it in archaeological record, is that we will find, a hole in the ground, a crucible filled with ores, and a heap of charcoal, and some air supply. By finding something like this very early is like, winning in a lottery. Because what we find is going to be a fragment of a slag or a fragment of a crucible. So I have to warn you at the beginning, there's always a lot of imagination in how we are interpreting these data, although I'm relying as much as I can and as many facts as I have. So we are all guilty of kind of, trying to interpret and to make the best story that we can, which is why I'm not telling you that being that lucky is very rare. But we were almost that lucky by finding the earliest slag samples from the site of Belovode, and I'm going to get on with that. But we never found crucibles, for instance. So, there are missing parts in our story, but we can just assume that they were there. Anyway, so the earliest copper smelting in Eurasia, before these Belovode Serbian stories started, was framed in a position where we were talking about the Tali Iblis evidence that was not so absolutely dated to the beginning of the 5th millennium BC, but just thereabouts, because that was the re-excavation of the spoil heaps back in the days. And the Çatalhöyük so-called slag, it was like a piece of slag, or something that looked like slag, that Melat sent back in the 60s to Austrians, and who basically confirmed it was a slag. But only lately we managed to repeal that evidence. So 2017, there was a paper in JS that we showed that the slag is a slag in terms of materials, but it wasn't a slag in terms of the smelting of metal. So it was basically burnt with the skeletons and with the Horizon 6 in Çatalhöyük, that in that sort of environment of the high temperature, there was a pocket of 1100 degrees that created this slag piece. So which means that it wasn't the evidence of the earlier smelting. But with the Belovode, the story changes. The evidence of around 5000 BC was well contextualized, was well dated. Back in the days, this is the biggest paper that I ever had. It's back in 2010 on the origins of extractive metallurgy. And I have to say it's the most cited paper of my supervisor, former supervisor, Tilo Rere, and I take particular pride in that because he's a beast in the field, right? But this is the most cited paper of his as well. You can see how these slags look like. I'm really glad that I'm in the audience. You don't have to explain what the slag is. But the particular thing about the slags in Serbia is that they are like very small, a centimeter or two. And the way that we found them is not by very careful excavations, is because the copper metal that was attached to the slag, patinated in green. And then that's how it was picked up in the soil. And then these samples were mixed with some 3,000 copper minerals in the box and sat for 15 years in the National Museum in Belgrade until Tilo and I came with a little magnet. And out of 3,000, we picked out 5 that jumped on the magnet. And that was the beginning of the slag research. So, so my first advice to all of you kind of looking for the earliest and the first is like be open and ready for anomalies and for something that is completely mislabeled, because not everyone really understands the archaeometallurgical process in archaeology. So that's kind of I would say the superpower that we have when we do this kind of science. But the idea wasn't to just claim, okay, this is the earliest, so everyone else just beat it. It was more like, let's find out what separates, say, the Iranian beginnings of metallurgy from the Serbian beginnings of metallurgy, because the ideas of the spread of metallurgy were kind of dominated by these single origins. It must have happened somewhere in Uri, somewhere in Anatolia, from which it's, from where it spread, like ex-Oriental looks, but is it ex-Oriental looks, or are we talking about multiple origins of metallurgy actually? So that was the task of my PhD back in the days. And I was looking into the sites around the site of Belovode, predating Belovode, post-dating Belovode, and this is the range and evidence I was dealing with. So when we talk of slag heaps in, say, the late Bronze Age, we talk about mountains of slags. But when we talk about slag heaps in the very early beginnings of metallurgy, that was a little heap at the, in my palm, and that was my my PhD. It was a whole 10 grams that I had, with which, the whole story actually started coming together. And there was also not just copper, but something else that came as a surprise. Just a little bit of theoretical framework, because I know that Thomas likes it as well, like going back and rethinking about how do we think about inventions and innovations. When I started working on these ideas of how do I conceptualize invention, I couldn't find much inspiration in archaeological work, because archaeologists are not too keen to talk about invention as a process. Usually when we see something innovative in archaeological record, we call it an innovation. But coming, to the very point of that origin and very process is not something that was very frequently addressed. So I went to the history of science to think about these, conceptualization of the invention. And invention is a radically new product. It has to be a recombination of technological components or application of an existing technology to a new purpose. So it's different from innovation completely in that sense that we talk about the individual inventing and creating something. And that's what I was after in thinking about my data. So little cartoons just to kind of, not bore you with theory, but I'm going to talk theory over them. What about simultaneous inventions? Is it possible when we think about that theoretically? Yes, if those communities were not in contact, or maybe if those communities were inspired by the similar factors or the similar stages of the evolution of society. So these are the ideas I was playing with of like whether metallurgy could have been invented in multiple places at the same time, say at the beginning of the 5th millennium BC. But, again, even if it was smelted somewhere, imagine the situation where, someone managed to extract some metal. Would everyone know what to do with it? Right? So there's many complex factors involved in inventing something. From our point of view, where we stand, well, of course, if you invent metal, you're going to, keep going because it serves us, whatever, 7,000 years later. But at the time, they were not thinking like that. They were like, what do I do with this shiny stuff? So you need to have different social mechanisms in place and understanding of the process to actually have it, consumed by a society or have a demand for it. So lots of factors apart from thinking, how was it invented? But when the invention affects the evolution of the system, then it is called an innovation. So only when we have the logistics, only when we have the widespread adoption, then it is innovation. But there is this fine line between invention and innovation that we kind of always play with when we look into the archaeomaterial science point of these things. And just another graph, because I get onto the hard data, is this so-called innovation curve. And it's a sobering diagram for me, because when we think about innovations in modern society generally, we always think of a curve, right? There's the beginning, there's like, people adopting it, and then there's a point where everyone is adopting it. But we rarely think about the fall of that curve. We rarely think about the dynamics of that curve. From our point of a 21st century society, we believe that everything was made for us. That everything that started at some point in prehistory had to survive so that we can live of it, right? So we very rarely forgive societies in the past for failing or for collapsing. We wouldn't recognize the blips of brilliance. Say, I don't know, imagine someone invented metallurgy 10,000 years ago just by smelting metal, but it never actually took off in society. So we wouldn't call it invention, if you see what I mean. So we rarely really forgive societies for collapsing, for not continuing with the idea, for not passing on the knowledge. We just think it doesn't exist. Which is why, for me, this graph is sobering, because where this early metallurgy, the earliest evidence for metal making falls, is here, right? It's like something is happening and people are making it. So this is where the 5000 BC here is. But this one, the very beginning, the very smelting process, is going to be like a holy grail of archaeometallurgy, like for as long as we live. It is absolutely archaeologically invisible. So what I'm talking about today is here, right? And I'm hoping and I'm opening this space for everyone to look for earlier, if it's possible to find earlier. I hope it is. But just to make sure that, when we talk what we talk, this is the line of reference I am in. This is where we are, and I'm hoping that there's going to be more surprises that in decades to come, and many years of research to come. So invention is a process, and it's got these stages of gestation, cradle, maturation, where gestation is like when you're creating some capability, you don't know what it is, but you're experimenting. Cradle is where invention has a reasonably functional form. You still keep experimenting. But maturation is where it's got a form that is no longer changed. And then we enter this innovation stage. And it rarely happens in one generation, could be several generations. So I came up with this kind of a model of technological invention innovation, where I'm acknowledging that, the moment when communities started recognizing these copper minerals as interesting to smelt, would be, this gestation, cradle, maturation. But this innovative phase would be adoption, adaptation, replication of the knowledge, and recombination for inventing something else. So what I was interested in is looking at what unites all these stages. Can I look under the microscope and figure out what will show up in every stage of the way? What will be the link to show me that it was one process? And I use the terminology of evolutionary archaeologists, but you can use whatever you like. At the end of the day, it's a technological mean or technological trait or a secret ingredient, if you like. But I was looking in my evidence, what can connect the dots for me to explain how was metallurgy invented? So here we are in the Balkans, looking archaeological in the whole space, not just Belovode, between, say, 6200 BC, when the earliest copper minerals are being used by Lepenski Vir people. I'm just giving you a quick overview of what is happening culturally. We have Vinča culture from 5400 BC, represented by these massive settlements of up to 100 hectares in size, and these massive cultural layers, the stratigraphy going up to 10 meters in, say, one of the Vinča sites. So it's really beautiful to excavate and really massive to excavate. And we have these first signs of social stratification. We have these first signs of potential inequality, where some graves in Varna have gold, or some graves in Durankulak have other prestigious materials. And we have at the time, just to give you the context of technology, absolutely mesmerizing ceramic production. This is all done without a wheel. So they're perfectly, symmetric. Some of them have gold dust still surviving, like in the graves of Varna. They are beautifully painted, and some of them are polished so intensively that they give off this high shine, like almost like a metallic shine. And also some of the pots were decorated with graphite to give more sparkle, even more shine to the pots. Just giving you the context of where the ceramic petrography, what the ceramic petrography and the ceramic technology tells us about the crafts of the people at the time. So what kind of a stage they were in at the time. So, and there we have the beginnings of the use of minerals. We have from the 6200 BC, as I mentioned, the first minerals being used in Lepenski Vir, so in the Danube gorges, these darker blue sites. They're using malachite beads to decorate themselves, but they're also using these black and green minerals, which were just sitting around, and I had no idea what they had, to do with it, but I took them for sampling. One very important thing to mention is that East Serbia is loaded with massive number of minerals. There are minerals of many colors. There are minerals of many different compositions. There's massive sulfidic bodies. There's polymetallic resources. Everything is available, at their fingertips, but they go only for green and black and green. Very important to remember. And then we have the Vinča culture metallurgy. These are the slag heaps, as I call them. So we have these tiny little slag pieces that we selected with the magnet, and a few of these slagged sherds that were actually not crucibles, but were pre-fragmented, I believe, to line the hole in the ground to keep it insulated for the smelting. Because we have a slag running on top of the sections, so they were not making like a proper crucible. And we have obviously metal artifacts, just to kind of have the whole chain operata complete. All of the work was done at the UCL laboratories. So main results are, well, the people were selecting from like 5200 BC to the end of the Vinča culture, these black and green minerals for a reason. They look similar macroscopically, they look similar microscopically, and they're similar in composition. They have copper and manganese in almost equal amounts. Then we have, just before these earlier slags, I found in some of the samples that looked like minerals, and I just picked them by chance. I have to say, this is total serendipity. When I opened them, they were actually not minerals. They had metal prills in them, but most of them were corroded already, which told me that they were somewhat smelted, but not entirely, not completely, not thoroughly, because there's some original mineral composition left here. And then we have, I hope you see it here, these consistent copper smelting practices from 5000 BC to 4400 BC, judged by these very colorful micrographs of early slags from 3 different sites. And the principle is the same. It's the same sort of a partially oxidizing, partially reducing conditions. So very similar recipe, but just different types of ores. What kind of ores? Not just black and green, which emerged to be the main types of ores being used for smelting, but also anything that is green and blue and greenish and bluish and violet and so on. These ores here, they were not only copper. They were actually aluminium phosphates, they were iron, arsenic phosphates, and so on. They were not proper copper ores, but they were green in color. And this is the point where it became clear to me that there was a lot of experimentation happening just based on the aesthetics of the appearance of the ores, until they figure out how they're going to make it, how they're going to actually produce all this copper. And there was a surprise in all this evidence of metal artifacts I had from a very well dated sequence in the site of Pločnik, which was the single horizon site. This little foil that when I analyze it, show me it was made of 12% tin. But it's not the type of a tin that you alloy with copper. It's the type of a tin that is very dirty. This tin bronze has got nickel and cobalt and arsenic and sulfur and antimony and lead and so on, telling me that there was not alloying, that they were rather smelting or coarse smelting the complex copper tin bearing ore. The same evidence comes from site of Gomolava, but I have to say it was published much earlier. However, Gomolava was the site and is the site that has multiple layers of occupation. So we were not sure whether it comes from the Vinča context, but Pločnik kind of connected it all together because Pločnik only has Vinča culture. Again, similar principle, dirty chemical composition. And we're just thinking, why would they do that? But then coming back to the type of ore that could have been used, I thought of stannite. Stannite has copper and iron and zinc and tin and sulfur, all these elements showing up. And we have these polymetallic origins of ores in Eastern Serbia, kind of the whole region is covered, Vinča culture is covering at the time. And when you look at the stannite now in the exhibition of minerals, wherever of the world, it's going to come out as very nicely polished mineral. It's going to have this blue and yellow color, if you go to the Natural History Museum, say in London, right? But if you think of the stannite in nature, unpolished, is actually going to be this copper component is going to patinate in green, and the sulfur-rich component is going to patinate in black. So what we have is the black and green stuff again. So my imagination or my interpretation of how it went is that they were picking up anything of a distinctive color in nature and working their way up from that point. And to argue the point that it wasn't just haphazardly produced or accidentally produced is to look at the working technique. So they knew what they were doing. Here we have just a light touch of the foil to be left, soft enough to be wrapped around something, while this little ring was beaten to death until it produced like a proper little object. The knowledge of working with tin bronze is different from working copper, because to recrystallize copper, you need 200 degrees and excess of 200 degrees. But to work with tin bronze and to shape it, you need the temperatures in excess of 600 degrees. So someone knew they had to raise the temperature. So it is intentional. It is not a haphazard invention. Okay, so why bronzes? Why did they come up with that? And it came to me that just around the same time, 4650 BC, we have exactly relatively close, on the other side of the Balkans, we have Varna and all these gold, more than 3 kilograms in this particular grave. So I just wondered, what was the color of these tin bronzes? Back then, I consulted Peter Northover, who was a co-author in the paper in Antiquity that came out, and he told me that the color of the tin bronzes is golden, but that no one actually experimented with that in terms of making tin bronzes. I said, okay, well, let's do it. I was already called imaginative for thinking that this golden color was the major drive for the tin bronze to emerge within the Vinča culture, as much as the golden color was the major drive for gold to be used in the Karanovo and Varna cultures and so on. So let's see. With the Faculty of Metallurgy and Technology in Serbia, we made more than 60 samples of binary and ternary alloys, so copper, copper tin, copper arsenic, copper tin arsenic, to make this color chart and see where do we sit with the composition that we have in archaeological record. And lo and behold, it was golden. So the composition of around 10 or 12% of tin gives off this golden color of the object. And bearing in mind that the earliest objects made of tin in the Vinča culture are not weapons, but decorative items, a ring or a foil to be wrapped around something, it just fits the whole idea that it all starts with aesthetics. It was published and featured in Nature Materials, so the reference here is for you. So how do we go about these theoretical ideas? Like, where is the invention? Where is the innovation? Coming back to these ideas of how it circulates in space and how do we get this trait, working in our favor, I would argue that this gestation stage was the stage of just picking these black and green minerals, right? And then playing with them from 6200 BC. And then this cradle stage is just before we have these slags, these almost molten, not really molten, but something in between copper mineral that looks like a metal is the cradle stage. And then we have this maturation stage, which is basically the process that is no longer being changed. Adoption is widespread. We have it all over the Balkans. It was being replicated. I think there's around 4.7 tons of copper implements preserved from the Chalcolithic period in the Balkans in the museums. But then we see the recombination, that element of like inventing something new, where we go for the black and green colors, but we invent something completely different, a different metal with a different color. And in the heart of all of that is the black and green. This is my secret ingredient. This is my technological mean, because this is the moment that, it follows from the very beginning through all these transformations into like copper and tin bronze metallurgy at the time. And when you ask me, where did metallurgy start? It did not start at 5000 BC. It must have started somewhere here. So before the maturation process, so somewhere between 6200 BC and 5000 BC, we have the earliest record of metal making. But that's like for someone, for someone else to research in the future. But this is the idea is here. What I found in 5000 BC is the mature process. So the experimentation was actually here. Okay, so it's a very dense graph. So I'm not going to harass you with like going into detail. What I want to say is that by doing isotope analysis of all these artifacts and everything that made it to the chain of operations, we know that they were using local Balkan resources, and there was multiple sources exploitation related to this Eastern Serbia. Something I haven't talked about a lot before is lead. So what I couldn't get into my thesis and in my early publications is because is this lead slag. So lead slag is found before copper slags. So it was found in the site of Belovode. I was hitting my head against the wall for like more than 10 years about how did that happen. I went around the excavation records. They are completely clean. This is a 5200 BC Vintra culture context. And this lead slag is around 700 grams. So I am here fighting for a gram of slag and building like a whole project. And then this pops up. And it was published as an object in 2012 and 2014 as an idea, like this is what we should look at next. But let me just give you an exclusive peek in some of the ideas. What we know about early lead is that we have this famous Yarim Tepe 1 lead bracelet from 6200 BC that must have been melted in order to be shaped into that. It wasn't galena, right? It was a molten metal. And then we have a lot of lead and galena in Çatalhöyük. That's something that I also kind of repolished and redid myself, but it never went into publication because I'm telling you again, I need to figure out why is this happening before copper and how is this happening at a very early stage. And looking at the early Balkan lead in the Vintra culture, even in the excavations of the site of Vintra in 1913, Vasic, who was excavating, he was finding these shallow pit balls that were used for lead smelting later in medieval times, but the shape is indicative. And then they were fired. There's some galena beads. There's some ethnographic record for that being used still by the Vintra villagers. There's a lot of smoke right now about how did that come together. And we definitely have lead production somewhere around in Donja Tuzla, 5450 BC, but also in Pietrele a little bit later in Romania. This is work by, in the 70s and 80s by my Yugoslav colleagues, Radivojević, Petar Glumac, and this is work by Sven Hansen and other colleagues in the region. So there is something fishy about lead going on, but it doesn't start at around mid-5th BC. It starts a little bit earlier. So let me tell you more about this lead slag. This is the date, like it or not. It's heavy, it's round, it's green, gray, white. It's completely different to what we have on the copper smelting. It's got proper mate, it's got proper phyalitic slags, it's got the residual arsenopyrite. If it were not in a clean context, I would say this is a medieval slag, but it is in a clear context. And there's nothing on top of Belovode because I excavated Belovode and surveyed Belovode. There's nothing late at that point. And this is found in the depth of like 2.5 meters or something within a layer. So it wasn't even closer to the surface. And then we have like a lead metal proper, like a whole priel, and with a little bit of arsenic and antimony. It all fits into the ore picture of the area, the mineralogical picture of Eastern Serbia. This is perfect. I just don't know how to fit the age and the whole vibe of this object. So two ideas for why. There was intentional smelting, but we need to find out how and why. And the second is that there is this non-intentional smelting because it was just an experiment and they abandoned it. That's something that I'm working with. But, you know, moving on, whatever way you look at it, the Balkans were pretty sensational because within, say, 500 years of inventing early metallurgy, of inventing copper metallurgy, there's a flourishing of tin bronzes because there's more than this Blochnik and Gomolava, there's more in Bulgaria. There's gold, there's copper, there's lead, there's a little bit of silver. I like to call it this polymetallic revolution of the 5th millennium BC Balkans. All of this changed the course of Eurasian metallurgy, the idea, you know, the ideas that we had about how did that evolve. Because, you know, these kind of a pointers at how early it was and what was the heart of these operations, I think shifted a little bit towards Europe with like a little bit different dates. It's open again for more debates and more findings. So the point where we decided to actually dig a little bit deeper and see how and why is the point when we invited Thomas Stolner and his wonderful team with Peter Thomas and Fabian and others to join us in excavating Jarmovac mine in Serbia, but also other teams with RGK for Belovode and Pločnik. And this is it kind of in brief. The book came out 2021 with 53 chapters and 33 authors contributing. We are still to write more stuff. This massive project was awarded by the AHRC. We had lots of experiments and, you know, lots of good fun apart from work for those 3 years of the project. It was politically very well recognized, you know, by the ministries of culture and so on. But, you know, it's something that follows projects like this. Just to give you an idea where the sites are and where we were working, a quick look into Jarmovac, which is something that is familiar to Fabian here and Peter, who's online, is the excavations that we thought it was the mine of the winter culture, but turned out with the dates to be a little bit later for the early Bronze Age, so 3500 BC. Still, this is the earliest Bronze Age mine we know of. Like, so it's like absolutely sensational finding. At the time, we are writing up the paper as we speak, and it's gonna see the light very soon. This is how the excavations look like. We had a good time, you know, building these. So you see Peter, you see Fabian, building all these, you know, safety features around the whole, you know, the shaft that was excavated. This is our collaborator Savo from Priboj, and this is us having multiple discussions in a tavern, obviously obeying all health and safety rules by sending buckets to the air and like all the other stuff that you can imagine going on. It was a really fun excavation and a lot of good results. In the site of Belovode, I can tell you this how it looks like. It looks like the main metallurgical activities were happening in the sort of in the most condensed area here, which is I don't know if I can call it Acropolis, but it's like kind of the densest part of the site. And then we have other kind of parts and some potential ditches. So for those who are, you know, excited about geophysical survey, this is how Belovode look like. You know, different clusters of communities living there. I mean, I had a really excellent excavation team. We really went down to the nitty-gritty of every feature, of, you know, dating it very carefully. One of the biggest achievements of this project is to confirm the 5000 BC. It's basically back in the days we were, you know, looking around, it should be around 5000 BC because the context was almost indirectly dated. Now we have the context directly dated to 49th century BC. That's close enough, right? So we just repeated the results. Extensive dating, and if you were expecting me to show you some very exciting, you know, copper metal workshops from the site, I have to disappoint you. This is the most exciting you're gonna get. So this is the area where the copper was worked. It had some little indentations in the ground that disappeared, but there was lots of slags. These red dots are slags or slag sherds, and these green are just green minerals. So this is it. This is the pinnacle of the excavations, finding the area where all of that was just kind of, scattered around the space, but it is 7,000 years old. So giving a little bit more credit. And then this is how it looks like. Again, similar types of slags. We even found some pot bottom embedded in the soil that could have represented an installation for smelting. We didn't find a smelter attached to it. We didn't find a metal attached to it, but we found a lot of ashes. And the ashes were rich in some of the, trace elements like copper and so on. So it could have been like that. It's difficult, these are ephemeral evidence very early on, but this is kind of the best we can pull out. And they look exactly the same. All the evidence is the same as the one that was collected many years ago and before the excavation. So it was a great achievement to be able to replicate the ideas and the evidence with a project as massive as this one. Similar, a lot of micrographs showing the copper production, similar type of recipes, basically repeating what I saw in my PhD thesis. And this is the hole in the ground. That this is, I believe, the closest we're going to have when it comes to representing the earliest copper smelting installations. That's how it looks like. It's a hole in the ground, potentially lined with this pot bottom or with some broken sherds, and that's where they were smelting their metal. We did some experiments to reconstruct the same setting, as you can see. So the pot bottom, and we invented obviously that it could have been a tuyere because there had to be some tuyere and so on. But we managed to successfully smelt metal in this one. So that's another evidence that it could have happened that way. And this is the earliest evidence that we have from this pit, which is basically a semi-molten copper mineral at the 49th century BC. So we were happy to say, like, okay, we came as close as we can to the dates that we actually proposed 10 years ago. The site of Pločnik has a little bit of a different configuration. It's near the river. The river is eating most of it. But again, similar idea of these clustered communities. The site is well known for the finding of these 40-something copper implements, the earliest ones that we have in Europe back in the 60s. And this is how it looks like towards the river. So the river is eating most of it, but you see how mighty the profile is, the stratigraphy is. These are like, I think this is the gradats, the middle phase of the Vinča culture. These are the houses, house, a pit, 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 for like a couple of kilometers. Massive, beautiful organization of the site. Again, very careful excavations. We're excavating a house. Every house has got a little bit of some metal workshop at the back. This is the idea. This is where the idea of like everyone doing metallurgy actually came together for me. And it was never the skill that was limited to like a metalsmith or like a specific craftsperson. Everyone were participating in metal making as a community. So I could imagine that their social organization was something akin to cooperative. Right, something that, they were kind of joining forces to make a metal to trade for something more egalitarian than you would imagine for the very beginnings of metallurgy. Similar dates, lots of little trinkets that we analyzed, beads of very similar situation, but no slags. So what I can say for Pločnik is that they were using raw metal produced in Belovode. We show that with lead isotopes, and then recasting and remelting and redistributing further. How do we reconstruct? We did experiments. 4 experiments. We had very limited data, little slags and slag sherds. Then I looked at these a little bit later, nozzles. I don't know how to call them, but we find these ceramic nozzles that could have been the tip of the blowpipes, right? There's no fire on them. They could have been used for that. That's the idea, because I don't know what else you could use them for. But we included them in experiments. So I'm saying we only had this, then we had to kind of come up with all the other factors that could, give us an idea of how it was actually done. We were lucky that in Serbia, you can just show up at the mine with a big sack and take ores, right? So like we just showed up in the mining area and we just took our ores for smelting. Not just any. We went for the mining regions that showed up in lead isotope analysis to be exploited in the winter times. So Rudna Glava, Majdanpek, Zdrelo, all of that showed up in analysis. So we went for the original stuff to smelt it and see how it went. And this is us, in Plochnik, we did experiments. We used the elderflower trees that grew by the river to actually, you see the person with the nails, that's me. It's basically we pull the hearts from the elderflower trees because they are soft. You can use them as blowpipes. We don't have bamboo trees for that, right? So we use the elderflower, and then we use the local river sand. And you may recognize some faces. There's a lot of archaeometallurgists from UCL came together. For those who know, David and Coulong and Loic and many others. They're all doing archaeometallurgy now in the world in different places. But there was a huge number of us who actually did PhD in archaeometallurgy and came together for the experiments. So we made these blowpipes with these little ceramic tips to use in experiments. We also made these crucibles. We never had crucibles, but you had to smelt in something, right? So we just kind of made them up. We crushed some original ceramic sherds to line the hole in the ground. So we used different scenarios, and you can see here many different designs of installations, like lining the hole in the ground with the ceramic sherds, like just clay in a crucible, just nothing. A pot bottom and a crucible, and just like a pot bottom. So, mix and match whatever we could find to see what's actually working in the end. And this is the very, the beginning of the smelting. We had, a huge team. I don't know if you recognize Bastian Asmus was also with us. So we produced a lot of slag. I have to say, we use music. This is another thing of the experiments. You are so bored, you get so bored if you don't have the music. There has to be a rhythm, because not all 6 people should be blowing at the same time. You need like 1, 2, 3, 4, like slowly rising the temperature, right? And for that, you need a drummer. So I paid the drummer to drum all day. And it was nice because people were wiggling, you just kind of, because there were at least three were happening at the same time. So you had people dancing, there was a good vibe, good mood, everyone kind of, jumping to, because pre-COVID, it wasn't really a big deal if you lick the blowpipe after someone else. And we, although there were 12 PhDs in archaeometallurgy, I'm going to show you how much we made. This is the metal we made. So it only shows that even though you have a PhD in archaeometallurgy, doesn't mean you're going to be a successful metallurgist. So this is all that we made from 12 different experiments. Why? It's because most of our metal went into the slags, right? So we were a little bit rushing it. We just didn't understand the kind of how you need to pace yourself. So it is a black art, if you ask me. Looking forward to coming back to these at some point and redoing it. But this is the lesson I learned. Most of our copper ended in the slag. And then some of that coagulated as prills, which is how we got the prills, by crushing the slags. But, it's not the same, right? And this is our little workshop. So what comes after is interesting. The day after, this is how it looked like. We smelted metal in this and this and this and this. There's no slags attached to it. There is no metal around it, because slag just, sucked everything in, and whatever we had to pick it up. And just gave me an idea. It was kind of like a cold shower at some point. Like, I would never know unless I have like an XRF with me and analyze the soil all the time, that they were maybe doing something at a very early stage. Because these little installations are so ephemeral that they will not survive as something visible, yet they all successfully helped in smelting metal. Right. And we replicated the evidence. This is a slag with the metal. This is the slag sherds. These are slags on some sherds. This pot bottom survived without any slag attached to it because the hot spot was a little bit above. That's why, nothing dripped on the pot bottom. So we reconstructed our archaeological evidence, but we also despaired with the fluidity, of the conclusions, that anything goes. absolutely anything goes, and we will never find the smelting workshop. It will be just little pieces and bits that we find in the evidence and kind of, scattered around. In terms of how we did in material science point of view, we managed to replicate the slags, right? So this is the Bellevue, the original slag. This is the experimental slag. So we did okay, although we overcooked the experimental ones. I'm just showing you the good bits of the micrographs. So we had more reducing conditions. So again, it is a dark art that needs practicing, and it doesn't mean that if you have a PhD in the subject that you're going to do it successfully. What is the connection with pottery to the metals? We had a PhD on the project that, to give you a short answer, there is a straight no. There is not a clear connection that smelting of copper happened because there were advancements in ceramic pyrotechnology. There could have been like close cousins, but it's not. We cannot find any technological connection. A whole PhD was done on the topic. If you want to see, it's a really nice paper by Silvia Amicone in Journal of Archaeological Science from 2020 on this topic. How much time we're going to have? Okay, 10 minutes. Looking at like what's happening in copper and with polymetallic deposits in Serbia, all of these minerals I mentioned, all of these stannite and violet stuff and malachite and bluish and scorodite and polymetallic ores and so on, they all exist in Eastern Serbia. So all of these that I'm telling you is a very plausible interpretation based on what we have in the data, open for more. In the publication of 2021, we went into another deep dive with lead isotope and provenance analysis to figure out which sources were used for metal smelting. I can tell you we just replicated what we knew. It is largely Eastern Serbian resources, but also we could also see the cluster of objects, like objects and slag sherds without a known source. So we could say that there were multiple exploitations of resources, but some we knew by the source, by the deposit, and some we knew by the clustering of the artifacts. It's kind of an indirect evidence that, we have another source that we haven't discovered. Again, multiple ways to look at this. Another thing to really bear in mind is Rudna Glava. I had a lot of discussion with Ernst and some disagreements with Ernst Bernicka on this topic. This one is just fitting some of the objects into Majdanpek. They don't fit, okay? But this one is fitting some of the objects with Rudna Glava. Rudna Glava is this pink line, right? So there is some agreement with this cluster of objects with Rudna Glava. But Rudna Glava is a radiogenic source. And if I use the lead isotopes, I will never get it right. So in order to kind of make more assumptions, I need to have lead isotopes and provenance analysis pointing me into one direction. But this is only trace element coming as close as you can. So it could be Rudna Glava, but it could be something close to Rudna Glava in terms of mineralizations that we are missing out in the evidence. That's as far as I can tell you. Rudna Glava is the earliest known copper mine in the region, dated to like 6000 BC, but we don't know who exploited it. We know it's Vinča culture, but we don't have slags from that, or we don't have objects from that ore, and it's very difficult to trace the use of Rudna Glava because of the radiogenic lead isotopes that we have from the mine. So it's a lost cause if you ask me at this point. Not much is coming from Medni Rid, actually, so nothing from Bulgaria. So very kind of Eastern Serbia related sources. And the fourth one is very interesting for me because it's a cluster of objects that is coming from a source, but I don't know where is the source. But it should be Eastern Serbia because the sites are in Eastern Serbia. So we use different methods to actually say, look, they were using multiple sources, multiple deposits, some of which we know of, some of which we still don't. But you can see that in the provenance of data. So some of them, and they're all in Eastern Serbia. And then something I'm gonna go through quickly, just because it's already in the paper out there, but it's something that is, can be redone so many times. I'm thinking about cooperation at this point. So how do you draw bigger picture from small slag samples? And from these experiments, how do we talk about organization of production and cooperation between communities at the time? Because I'm telling you, this is happening in Serbia, this is in Bulgaria, these are Vinča culture people, these are Karanova people, they live at the same time. What is the connection? Were they communicating? How were they communicating? And what metals can tell us about communication? For that, I used a method that is called complex networks analysis or modularity analysis. What does it mean? Means I'm going to create a network based on, say, chemical composition, and I'm going to use special algorithms that will give me within this network the clusters of data called modules. So within a cloud of the network, some data will be more connected, and that's going to be a module. That connectedness shows similarity in chemical composition, and that implies it possibly comes from a similar source or a similar set of sources used over a certain period of time. But it's like a pool that is homogenized in a way, right? So paper published in 2017, where we used the same data sets, these 410 copper artifacts, 80 sites across the Balkans, and we came up with these three modules. I say we, it's my friend, physicist, she's in social physics, not anymore. She went for the data mining company because they pay more money than academia. But we published this paper in Journal of Complex Networks. And then what was very interesting about this paper is that you can randomize these models, say 10,000 times, and still get very good results. So this is the only mathematically valid model that you can use in inferring any conclusions from these clustering of objects, clustering of data sets, where you can actually show why we have a probability value for this. We can show that this is not a random network, and that you can, after 10,000 tries, we're actually going to get to the same result. So that is what I call robustness. Robustness is this is the only kind of robust method that we have right now, but it doesn't mean that that more will show up. However, I have huge faith in this one because we ran the model 10,000 times to see how statistically significant is this picture, and it shows very good results. So what I can tell you is that these modules are created without any information on geography or cultural chronology. I only gave the algorithm chemical data and later the location. And it gave me very significant results. Why? When I look at the breakdown on different periods of this, say, exchange of metal and this modularity and networks of interaction, I can tell you that one of them is totally representative of the Vinča culture and its connectedness with Duran Kulak, of which we know. One of them is totally representative of Karanova culture. One of them is one-on-one Bodrog-Keresto culture. So it just gives me mathematically modeled options for archaeological cultures in the Balkans while I'm kind of plotting these trace element data sets. So it's something that I didn't know I'm going to find in the data sets, but it's basically validating what we know from ceramic typology, but in a very mathematically solid way. What I can tell you about the, coming to the end of it, how important were the metals? Well, obviously at the time, we can see these scepters, so these objects looking like scepters. So there was something of the social status of, having all these objects in hand. But there's also a find from Serbia. So late Vinča culture, around the site is called, oh my God, it escaped me now, but it's in Western Serbia. It's going to come, Stubline, yes, where a colleague of mine, who's actually a cousin of mine, actually excavated. But Serbia is so small, everyone's a cousin. He excavated, and I remember he was very excited at the time because he found these little figurines and this big figurine, and then around them scattered very, very nice, like meticulously modeled clay figurines that represent metal objects typologically identical to what was circulated at the time. And there was a hole on the right shoulder. So obviously this is a reconstruction, but there was only one big one with something that looks like scepter, and then 40 others or so, attached in association with these little clay models. I really want you to spot that, this is not the peak of artistry when it comes to figurines. It just looks like a kid did it, right? But look at the meticulously made little clay objects. They represent artifacts. So the intention of the artist was the objects, not the figurines. My colleague / cousin calls this Alibaba and 40 Thieves. I think it's non-inventive. I think if you look into the Alpine region and into the Brother Grimm's, exploring the fairy tales of the miners, you can find a much better archetypes of what it means. It's much more closer to what we know of the story of the Snow White and the dwarfs, where we have people going, into the Mother Earth and extracting whatever they need to extract. And maybe this biggest figurine was a deity. Maybe this biggest figurine wasn't a Snow White, right? But it was something like a big figure to which maybe they were, offering anything, not diamonds, but whatever offerings they were. But I leave that to people who work on ideologies. I just say that this is it's a stark resemblance to the archetypal story of these dwarves going into the into the land, into the shafts, and mining for the precious metals. And just once again to show that this is absolutely the same, that typologically they are corresponding to each other. So understanding early metallurgy in the Balkans, I can say the earliest metallurgy in the world is the consequence of cultural choices as well as technological choices, ore and metal colors as well as object forms and uses. There is an evidence of community cooperation, not an individual smith. We don't have one person doing it all. We have a whole community cooperating. Both Belovod and Plotching have a lot. I'm going to say, I didn't want to swear. I had loads of metals, right? Lots of minerals, lots of malachite all over the place. So they are all working on it. They are all cooperating to make it happen. It is very common in everyday life. It is not socially restricted to any context. It is of limited functional use in everyday tasks relative to existing materials and tools. It is not evidently transformative of economic or social activities and structures. We don't see a big house in the middle of of the site. We don't have so much evidence about anyone being richer than the others. Only towards the late Vinča culture, in the sites like Divostin and so on, we can see some accumulation of wealth, but not in the sense where we have kings and queens and princes and so on. A little bit of that. There is just one archaeologically visible aspect of broader material and social cooperation and connectivity across the Balkans, which is the metals. There are other options, there are other economical options that they were using, like trade of obsidian or whatever else you can imagine when it comes to subsistence and so on. So it is not the only and the most flashy, option happening at the time. And it is only comprehensible through an interdisciplinary approach. Otherwise, we just repeat the old narratives. Just because metals were introduced into society doesn't mean that the societies went berserk and completely changed their structure. It was a very slow transformation. Apparently, when you look at the bigger picture of social complexity and evolution, it took thousands of years. Where can we go from here? Thinking about the polymetallism, the polychrome revolution of global metallurgy, just put it out there. I gathered everything that was used, all copper minerals, between 5th to the 2nd millennium BC globally. And I can tell you there's a pattern in the colors, whether it's like a blue-green, metallic gray, or red and yellow. All minerals here were producing copper, arsenical copper, copper tin bronze, the arsenical tin, copper, bronze, silver, gold, iron, lead, all of the metals, until well into the, I guess, Roman times and so on. So it gives you an idea that when we talk about transmission of metallurgical knowledge, I imagine it's like a handful of green, a pinch of yellow, two handfuls of blue and so on. This is how the stories were being transmitted. It had to do something with the color. Otherwise, we wouldn't have this as colorful as it is before us. And when we think about the beginnings of the global metallurgy, I put this map together with Ben Roberts, and I have to say, we've been sitting on this for 10 years, this idea. We put together these heartlands of metallurgy. Obviously, South America is an independent one, right? So there's definitely multiple origins of metallurgy. It was always a question, what happens in this region here? But even if we look very close here, so between like 5th to the 4th millennium BC, say Anatolia, Iran, Balkans. Let's compare the timelines. Here you have copper, lead, copper, tin, gold, and silver. In Iran, we have copper, lead, gold, silver, copper, arsenic, and then copper, tin in the end, in terms of the sequence of the chronology of the metals. In Anatolia, you have copper for at least 3,000 years, and then silver, and then copper, arsenic, and then all other combinations before copper, tin, as tin, bronze, or these brass, right? So what it tells me is that it wasn't just a technological choice, it was a cultural choice. There's a lot of, each sequence here is different. So even within these kind of spaces that were allegedly cooperating, around the same time, we have completely different sequence of the beginnings of metallurgy once we arrange all the chronologies that we know. What is that telling me? It was never about technological knowledge. It was always about the cultural choice. The knowledge was out there. It was just what flies at the time, what was being in demand at the time. And I thank you, invite you to read the book that we wrote. And I know I won't be reading it anytime soon. It's got 700 pages, but you're welcome to it. Thank you very much.